All right, guys, we're back with section 5 of chapter 1. We're going to talk about equations today. And so previously we simplified expressions, and now we want to solve equations with one variable and then solve equations with two variables. So we have a couple pieces of vocabulary here: an open sentence, an equation, what it means to be solving, solution, replacement set, just plain old set, element, solution set, and identity. So it might sound like a lot, but we'll go through it all as we proceed through the lesson. So a mathematical statement that contains algebraic expressions and symbols is called an open sentence. A sentence that contains an equal sign is an equation. So an open sentence is just like a mathematical sentence. All right. If it has an equal sign, then we call it an equation. And you can see even the word equation almost has the beginning of the word equal in it. So an expression is like 3x plus 7. There's two terms there. There's the product of 3 and x and 7. And then an equation is if it's set equal to something. So 3x plus 7 equals 13. So finding the value for a variable that makes a sentence true is called solving the open sentence. This replacement value is called the solution. In other words, the number that you put in for x that makes this true would be the solution, and figuring out the number of x would be solving it. So a set of numbers from which replacements for a variable may be chosen is called a replacement set. So that's kind of like the numbers that you can pick from to see if they would be a solution. A set is a collection of objects or numbers that is often shown using braces. Now, when I mean braces, I don't mean the stuff on your feet or on your toe, stuff on your teeth. I mean these kind of grouping symbols. Each object or number in the set is called an element or a member of that set. A solution set is the set of elements from the replacement set that makes an open sentence true. So here we go. You have a set. It could be a bunch of numbers. A replacement set would be the numbers that you need to check to see if they would work in the equation. The solution set is the number or numbers that make the equation true. Okay, so just kind of throwing some vocabulary at you there. So find the solution set of the equation 2q plus 5 equals 13 if the replacement set is 2, 3, 4, 5, 6. Notice how they put 2, 3, 4, 5, 6 in braces, and that is the replacement set. That is the set of numbers that we are going to test to see which one makes this equation true. Whichever one does, then that is the solution set. So here we go. We're going to use a table to solve, and we're going to replace q in that equation with each value in the replacement set. So here we did it really, really quick. If you put 2 in, you get 2 times 2 plus 5. Is that 13? No, because 2 times 2 is 4 plus 5 gives you 9. It's not equal to 13, so it doesn't work. Same thing happens with 3, 4, 5, for 3. Once you get to 4, 2 times 4 is 8. 8 plus 5 is 13, so that's true. And we just continue checking the numbers just to make sure there's no other solution. Now, in this case, there's only going to be one solution. But just to be thorough and make sure that we cover all our bases, we check them all. And since the equation is true when q equals 4, the solution of the equation is q equals 4. So you could write the solution set as just 4 inside braces, because usually a set, remember, is a number or numbers placed within braces. Since the solution to this equation is only 4, the solution set is just only 4. All right, so let's find the solution set for each equation if the replacement set is 0, 1, 2, 3. Go ahead and pause the video and hit play when you're ready. All right, we're back. So for the first one, I'm just going to make a table, and for the value of m, I'm going to do 0, 1, 2, 3. So you could do 8 times 0 minus 7 equals 17. Is that true? Well, 8 times 0 is 0, minus 7 is negative 7, so that's not going to work. 8 times 1 minus 7 equals 17. No, because 8 times 1 is 8. 8 minus 7 is 1. So That's not going to work. If you put in 2, 8 times 2 minus 7, is that equal to 17? No, because 8 times 2 is 16, minus 7 will give you 9. That does not work. And then 8 times 3 minus 7, does that equal 17? Yes, it does. 8 times 3 is 24, minus 7 is 17, so that works. The solution set would just be 3. Okay? Now we go ahead and we do the same thing for 1b, and it turns out that the solution set is just 2. I'm not going to run through all of that, but if you wanted to go over that in person, reach out to me and we can go over that one together. Okay? All right, you can often solve an equation by applying the order of operations. So if I want to solve 6 plus the quantity 5 squared minus 5 divided by 2 equals p, I have to apply the order of operations in order to simplify the left-hand side to see what the value of p is. Notice it's a multiple choice question. So this is kind of like PSSA or Keystone practice. You need to apply the order of operations to the expression in order to solve for p. So let's solve it. Go ahead. Now we have the original equation, so we're going to go inside the parentheses first because that comes first in order of operations. Remember PEMDAS, please excuse my dear Aunt Sally. And remember, addition and subtraction and multiplication and division is whichever comes first from left to right. So we go inside the parentheses, we have an exponent, so we apply that first. We're not done inside the parentheses, so we replace the 25 minus 5 with what it is, 20. Now we have addition and division. Do the division, and then the addition, and you get 16. So the correct answer is D. All right, here's one for you to try. Go ahead and pause the video and hit play when you're ready to check your answer. All right, we're back. So the first thing we have is parentheses. So we do that first. 9 squared divided by 5 minus 2 is 3. Then you have division and exponents. So you do the exponent first. So 81 divided by 3, because 9 squared is 81. 81 divided by 3 is 27. So the solution is t equals 27, or if you wrote it in set notation, it would just be the set of 27. Pretty cool stuff, huh? All right, let's go ahead on to the next one. Sometimes equations have a unique equation, or excuse me, solution. That means they just have one answer that will work. Other equations do not have a solution. So let's solve this equation. 7 minus the quantity 4 squared minus 10 plus n equals 10. So let's go ahead and use the order of operations. So inside the parentheses, we have exponents. So 4 squared, replace that with the 16. Still inside the parentheses, so you do the subtraction, which is 6. 16 minus 10 is 6. Now you have addition and subtraction, so you're going to apply the subtraction first. 7 minus 6 is 1. 1 plus n is 10. And then the only value for n that makes the equation true is 9, because 1 plus 9 is 10. So therefore, this equation has a unique solution. In other words, there's only one answer that's going to work. In this case, it's 9. Let's look at this one. If I have n times 3 plus 2 plus 6 equals 5n plus the quantity 10 minus 3. Now, it looks like a lot of crazy stuff, but just simply follow the order of operations. You have parentheses. So we'll do this set of parentheses first. 3 plus 2 is 5. Then we can do this one. 10 minus 3 is 7. Now, if you notice the n times 5, you could think of that as 5 times n. Now look at this. You have 5 times a number plus 6 equals 5 times the same number plus 7. Well, is that ever going to work? No, because you're multiplying a number times 5 and adding 6 and then saying that's going to be the same thing as if you multiply 5 times the same number but add 7. No matter what you put in for n, it's not going to work because you're multiplying that number times 5 and then adding a different number to it on each side. It's never going to be equal. So we would say that the equation will never be true, and therefore there is no solution of this equation. Okay, here's a couple for you to try. Go ahead and pause the video. Hit play when you're ready. All right, let's try 3a. So 8 plus 4 is going to give you 22 plus m equals 5 minus 3 equals 2m. And then you could subtract m from both sides, and you get 22 equals m. So that's the answer to that one. 3b, let's check it out. We have a lot of stuff going on here. So let's do the parentheses first. You would have 8 times 4 times k plus 9 times 5 equals 36 minus 4 is 32k minus, finish my parentheses, 2 times 5 is 10. Okay, now I have multiplication. 8 times 4 is 32k plus 9 times 5 equals 32k minus 10. And you can kind of see what's going to happen. So both sides have a 32k, and one's adding something and one's subtracting something. So this is probably going to be no solution. 32k plus 45 equals 32k minus 10. No, that can't happen because you can't add a different number to the same number and say they're equal, right? So this one is no solution. Okay. All right, so an equation that is true for every value of the variable is called an identity. In other words, you get one thing on one side and it's equal to the same thing on the other side, so it's an identity. It matches itself. So let's solve this one. Now notice you have a bunch of stuff going on here. You have parentheses here, brackets, and parentheses here. So we're going to start by just working through the parentheses, the grouping symbols from left to right kind of here. So 2 times 5 gives you 10, and then 10 minus 8 gives you the 2. And then you can distribute the 2 to the 3h plus 6 and get 6h plus 12. And then on the right-hand side, you have 2h plus h. You can add those together because they're like terms. So you get 3h plus 6 still in the brackets times the 2. Now the 2 distributes into the brackets and you get 6h plus 12. Now notice you're multiplying a number times 6 and adding 12 on both sides. So no matter what you put in for the number in this case, you're doing the same thing to it. So you're going to end up with the same answer on both sides regardless of what value you put in for h. So the equation will always be true, and then your answer is going to be any real number. Right? Because you can plug in any real number and it will work. That's an identity. Okay, so I want you to go ahead and try these ones and go ahead and pause the video when you're ready. All right, we're back. So I'm not going to work through step by step each one of these. If you want me to go over one of these, definitely reach out to me and I'll help you out. But 4a is all real numbers. 4b is no solution. 4c is all real numbers. And 4d is 8, actually has a solution there. Okay, so for A and C, you get an identity, so both sides are the same. You get all real numbers. For B, both sides, it simplifies down, and they are not the same thing. And no matter what you put in for B, it's not going to work out. And for D, when you simplify it down, you get one unique solution, and it was 8. All right, guys, that's it. We got one more video for this section, and we're going to talk about solving equations in two variables, and we'll see you there.